On a hot summer day, Ohio University requires 2,500 tons of chilling load.
Currently, Ohio University meets much of its heating and cooling loads with natural gas boilers in the Lauschie heating plant, emitting 21,000 metric tons of CO2 equivalents per year. We propose to meet the heating and cooling demands of Ohio University with an anaerobic digestion and biomass co-production system. AD is the microbial breakdown of organic matter in the absence of oxygen. Anaerobic microbes are selected for this process to create biogas methane, which can be collected and burned to produce energy.
Proposed anaerobic digester will use food waste from the compost facility and locally grown miscanthus to produce biogas. Both inputs need to be broken down into smaller pieces before entering the digestion tank. The size of the tank will be calculated based off of a 35-day retention time to allow for high conversion rates. The tank must be between 30 to 35 degrees Celsius for optimal conversion and growth.
The solids in the sludge are removed through a centrifuge, where the remaining liquids will be treated and returned back to the surrounding soil that is used for the growing of miscanthus. Biogas created will be gathered in the headspace above the digester and released for treatment. The biogas must be passed through a scrubber to remove the carbon dioxide and hydrogen sulfide. The treated biogas product is then sent to a combined heating and power unit that will pressurize the biogas, which will power the shaft that spins the generator, creating electricity.
There are many possible associated risks that are attached to the implementation of an AD plant. Some of the major risks include feedstock availability, the ability to produce electricity year-round, and the possibility of feedstock contaminants such as non-compostable items. The plant will require a plant manager that will oversee the production of energy, and a second plant manager will be required for the wastewater treatment facility. Ohio University compost facility staff will provide feedstock transport. A control engineer and the several operators must always be on site to monitor the process.
Utilizing the CREST Excel file for anaerobic digestion, we were able to determine that the levelized cost of electricity generated by miscanthus-fed biogas production system is approximately 19.05 cents per kilowatt hour. The most influential part of the levelized cost of electricity was the feedstock expense, which we found to be on average between $41 and $58 per ton.
Ohio University adopted a sustainability plan in 2009. In 2017, President Nellis signed the Paris Agreement, continuing OU's commitment to sustainable choices. One sustainability goal is to increase renewable energy generation and to reduce university-wide CO2 emissions. Implementing an anaerobic digestion system will help contribute to reaching these goals.
Life cycle analysis is a technique to assess the environmental impacts associated with all of the stages of a product's life, from cradle to grave. The life cycle greenhouse gas emission of the proposed anaerobic digestion plant is 7.4 metric tons of CO2 equivalent, compared to the current Lauschie cooling load emissions of 21,000 metric tons as of 2018.
Energy from the proposed AD plant would cost 19 cents per kilowatt hour, compared to the current price of 13.4 cents per kilowatt hour for natural gas. However, we would reduce greenhouse gas emissions by 99% compared to the Lauschie plant.